Hi, physics friends, and welcome to 3.2, which I have entitled The Big Three. And I've called it The Big Three because we're going to be learning three brand new equations today that all involve acceleration. We already know one equation, which is velocity equals displacement divided by time. We're going to be learning three more today, and you'll have to have these three memorized. So I'm going to put them down. I want you to be practicing them. I've also got three example problems that kind of go along with to show you how to use those three equations that we're going to learn today. So let's get started. We'll start off with the first equation that we know, and we all know that velocity equals your distance divided by your time. Sometimes I say displacement, distance, kind of the same thing. How far you go divided by how much time it takes. Now, you can only use this if there's no acceleration. If you're getting faster or getting slower, this doesn't work. This doesn't work. We discussed in 3.1 that there's an equation to find your acceleration. It's your change in velocity divided by your change in your time. And remember that change in velocity is your final velocity minus your initial velocity over final time minus the initial time. Now, if I get rid of this part, and then I'm going to leave this piece the way it was, the delta t, and then I move this delta t over to the other side, and then I move the VI over, you'll notice that I get this. I get VF equals VI plus A delta T. And this is actually the very first equation. You know the first equation. We got it in 3.1. I'm just going to be writing it in a different way. I'm just moving things to one side and the other. So here's the first of the big three. It's VF equals VI plus AT. It's just a variation of acceleration equals your change in velocity over your change in time. I leave out all the Greek symbols and things like that just to kind of simplify it. The second of the big three is this. VF squared equals VI squared plus 2AD. The A stands for acceleration, and the D in this one stands for displacement. Our third equation, D equals VIT plus 1/2 AT squared. D, displacement, T, and time. Now, you'll notice some similarities and differences between the three right away. One of the similarities is each of them has the letter A in it. So we use these equations when there is acceleration. Secondly, the differences between them. You'll notice in this equation right here, the first one, there's no displacement. In this one, it's missing the time. In this one, it's missing the final velocity. So these are really basically tools, and what you have to do, depending upon the problem, you pick which of these works best for you for your own situation. So this kind of brings me to how do we solve physics problems? Steps to solving physics and life's problems. The first step is to understand the problem. And what do I mean by that? I mean, when you understand the problem, you know what are they looking for? What's the problem looking for? What's the goal? And you also know, what do we have? What do we got to work with here? What are we looking for, and what are we given? The second step to solving any physics problem is to figure out an equation that relates what you're looking for to what you're given. This third step is to solve it. Actually, you'd substitute your things in and then solve it. And then the fourth step, and the fourth step is the most important. You'd think it's all done right now, and you'd be right. The most important step in solving any physics problem is, does it make sense? Does this seem correct? Now, I'm going to go through 3 of these problems, and I'm going to apply these steps to solving each of those problems. I'm going to see what is the problem giving me? What am I looking for? There's probably an equation that relates those things. I'm going to substitute what I've got in, and I'm going to solve it, and then I'm going to always ask myself, does it make sense? That's the most important thing you can do. If you get a number that doesn't make sense, you probably did something wrong. Go back and look for a sign error. A lot of times something was supposed to be positive, and it ends up being you put it in as a negative, or it's a negative and you're supposed to be a positive. That's usually what the first thing I look for. Did I get my signs correct? Before we go on my questions here, I wanted to show you a video. The Tesla Model S. The Tesla is an all-electric car that it's incredibly, because it can go from 0 to 60 in 2.8 seconds. And the normal car can do it in 3.2 seconds, but you can get an upgrade. It literally was like, I think $7,800 or like $8,000 you could pay to improve your battery, and then you can do it in 2.8 seconds. So you could shave 0.4 seconds, like a half a second off your 0 to 60 time. And it's really fun because there's a video that shows a car dealer taking people for rides and actually not telling them what they're about to experience, but then just going 0 to 60 in 2.8 seconds and filming their reactions.
That's 60. You don't expect it, right? Isn't that neat?
That's awesome. I'm really mad that the option is insane. Like, it's not like just.
Why, that's perfect, isn't that good?
That's a random, like. What's the feature?
I've always wanted to ride in one of these cars.
The car's insane, so why not have, like an insane mode, right?
Makes sense.
So you just come to like a complete stop.
All right.
And then before you know it,
Oh, Brooks! What the fuck?
70 miles an hour.
Brooks! Oh, Yo, first of all, you can't do that to people. Like, you gotta give people fair warning.
Why?
Like, you can't just say,
Yeah, you can.
Brooks,
What?
I think I in your seat. No, you're good.
Exactly.
So you're going to go insane?
Yeah, go ahead and press the insane button.
I'm not going to throw up.
I hope not.
Okay, that's enough. Okay, I got it. Holy
You okay?
that's not funny.
You okay? Does it feel like a roller coaster?
Oh man, it did.
Yeah. Isn't that weird?
But there's no build up.
No.
It just
goes.
holy. When do you do that?
All the time.
No, you don't.
Yeah, I do.
No, you don't drive
do.
like that.
No, not all the time.
Oh my God. I thought it was gonna. What's the word? Gradual.
Take off? Are you okay?
I think so.
Okay, so stop. Start. So I'll come to a complete stop. So totally quiet. And then that's the insane button right there. And then
Oh my God! Oh my God, Brooks! Oh my
that's
God!
70 miles an hour.
No way! No way!
Isn't that crazy?
Oh my God!
Basically, right there, that's the sport and insane.
So there's a
Right?
button on the dash that you can
Isn't that
push.
crazy? Who puts an
Apparently.
insane mode on the car? So basically, you press that button.
So you ain't got to worry about you staging is simple. Cause
no,
the
you
bitch
just
ain't gonna roll.
you go.
damn it, that 65 miles an hour. Right there.
This is faster than McLaren on the start, ain't it, guy?
Yeah. I mean, takes you by surprise, right?
Boy.
Ready? Boy, that.
Ready?
Sure. Okay.
I'm sure.
I'm just gonna go when it turns green.
Okay.
Another Tesla. You see it?
That is awesome.
So that was 65 miles.
I
an
can do
hour.
that every day. Every day, Brooks. Every single day.
Love to drive one. Looking forward to it. But I've got a couple of questions. You know, these people had a lot of really good reactions to what they were experiencing, but let's put some numbers to it. So I just made some problems up kind of around this. It says the all-electric Tesla model P85D can go from a standstill to 60 miles an hour in 2.8 seconds. What is the acceleration of the car? And part B, how many G's is that? The word G we hear all the time, like it was like 6 G's when I took this corner. I'm going to explain to you what that means. So first of all, when we look at how to solve a problem, number one, understand the problem. What are we looking for and what are we given? So what am I looking? I'm looking for what is the acceleration. It says it right here. So my acceleration is question mark. What do I know? I know that it goes from a standstill. That might not seem like a number, but believe it or not, that means its initial velocity is 0. 60 miles an hour, that's my final velocity. I'm not going to be able to use that because I want to have everything in meters and seconds. So I'm going to take 60 miles per hour, and I'm going to have to change hours into seconds, and then change miles into meters. So I take 60 times 1600 divided by 3600, and I get 20. It's like 26.7 meters per second. And the other thing I know is 2.8 seconds. That's a time. 2.80 seconds. So here's step one. What am I looking for, and what do I have? I've got these things. Now, I try to relate that to one of the equations. Is there an equation that has VI, VF, A, and T in it? So I look through here. VI, VF, A, and T. That's it. I can't use the second one because I don't have the letter D. There's no distance or displacement asked. Nor is there in the third one. I don't have displacement, so I'm not going to use the second or third one. So I'm going to select the first equation. So that's step two. Figure out an equation that relates the goal to your given. So here's my equation. VF equals VI plus AT. Step three in this whole thing is substitute things in and solve. So I know VF, that's 26.7. I know my initial velocity, that's 0. That just goes away. I'm looking for my acceleration, so I leave it as the variable. And my time is 2.80. So now I solve. Take 26.7 divided by 2.8. So take this number divided by 2.8. And I get 9.52. My acceleration is 9.52 meters per second squared. And that seems to make sense to me. You don't have a handle on accelerations yet, and you will in just a moment. Part B asks, how many G's is that? It turns out, and you'll learn this in an upcoming lesson, that 1 G is 1 acceleration of gravity. And 1 acceleration of gravity is 9.80 meters per second squared. So if you take this number, the question is how many 9.80s is this? So you take this, and we can do a dimensional analysis with it, or we just divide by 9.8. It comes out to 0.97. My dimensional analysis, what it would be, I would say I've got 9.52 meters per second squared. It turns out there's 9.80 meters per second squared in 1 g. So this turns out to be 0.97 g's. These people up here aren't even pulling 1 g. They're almost there. In that acceleration, you're almost at 1 lateral g. Example problem number 2. Assuming the exact same thing, how far does it go? So here's where we're going to go. How far? That's a distance. So I'm looking for my distance. I know that it goes, my initial velocity is still 0. I know my final velocity is at 26.7. And now I know my acceleration. (9.52). Notice all of my numbers are in meters, seconds, and meters per second. Everything has to be aligned. So that means my displacement is going to be in meters. So I'm going to see if I can find an equation that has VI, VF, A, and D in it. So here, the second one, VI, VF, A, and D. There's no time, so I'm forced to kind of use this second equation. So VF squared equals VI squared plus 2AD. VF 26.7 squared equals 0 squared. 2 times 9.52 times my displacement D. So I just take 26.7 squared divided by 2 and then divided by 9.52, and I end up with 37.4. So my displacement is 37.4 meters. And that seems about right. I mean, that's probably around 3 feet to a meter roughly. So it's probably around 100 feet. So you can get going you can get going 60 miles an hour and 100 feet in this thing. And then my last example. Let's compare this to a top fuel dragster. I know from experience when I watch these things, they can get up to 331 miles an hour in a quarter mile. And I know a quarter mile is 400 meters. So here we go. What acceleration does it have? So what acceleration is what it's looking for? I know the final velocity is 331 miles an hour. That's not very helpful. So I'm going to have to take 331 miles per hour and then do the same thing, change hours into seconds, and then change miles into meters. So 331 times 1600 divided by 3600. I get 147. So my final velocity is 147 meters per second. My initial velocity is a standstill. And now I know my distance. My distance is a quarter mile, or 400 meters. Now I'm going to assume that's got 3 significant figures, so I'll just put that over there just to remind myself. I pick an equation that's got all of these pieces in it, and it turns out it's that last one. D, well, it's equals VIT plus 1/2 AT squared. I think. No. I don't have time, so I know that this is not the correct one because I don't have time. Let's try VF squared equals VI squared plus 2AD. I think this one will work for me. 147 squared equals 0. 2 times, I don't know the acceleration, and my displacement is 400. So, yeah, that looks like it. 147 squared divided by 2 divided by 400. I get 27.0. So my acceleration here is 27.0 meters per second squared. How many G's is that? So you divide that by 9.8, and now we're talking about something. These people are under about 2.75 G's. .75 times the acceleration of gravity. So your human head weighs 8 pounds. Now all of a sudden your head weighs 22 pounds, and that's why you're going to have to strap that down, because your neck isn't physically strong enough to lift 22 pounds, pushing it forward, looking down the track. So just kind of in summary, understand the problem. Look for keywords like standing still, stopped. Those mean things. What's the thing we're actually looking for? Try to equate that to one of the big three. We're going to get more and more equations, and this flowchart is going to become more and more important. How do you find what you're looking for? And then, does it make sense? Again, the most important part, does it make sense?